Hello. You might have seen that painting that portrays Isaac Newton holding a prism and separating the white light into all the colors of the rainbow. He is using the prism for dispersion of light, and that happens because the index of refraction of a medium depends on the wavelength of light. Light trajectory bends a different angle for different colors. Consider a prism to which you send a ray of light. For now, consider it is a single wavelength. Imagine you are using a laser that, as we will see later in this course, emits a monochromatic light.
You are looking at an industrial laser, which emits an extraordinary light not to be found in nature. It can project a spot on the moon, or at closer range, cut through solid metal. I will show you.
Kind of. The beam of light will follow Snell's law at its interface. It enters from air to the prism, and it leaves from the prism to air. A way to characterize this prism is by determining the angular deviation of the beam of light. Of course, this deviation will depend on the incident angle. To calculate this, we only need to extract some geometrical relations from this scheme. Which combined with Snell's laws gives us that the angular deviation delta is θ1 plus θ2 minus a, where a is a parameter that depends on the shape of the prism. The angular deviation will depend on the incident angle. The shape of this dependence presents a minimum for a specific incident angle. This is something easy to verify experimentally. For the angle that presents this minimum, because of the symmetry of the plot about that angle, the incident angle is equal to the exit angle, which simplifies the last equation to We can use this final result in Snell's law to find a way to determine the index of refraction of the prism by measuring the angular deviation. N is equals to sine of A plus delta over 2 over sine of A over 2. The prism can be used as an instrument to study the light coming from a source. The fact that it can decompose a light beam into its component frequencies allows us to get information about the emitting source, even though the source is thousands of light years away, such as distant stars of galaxies. A spectrometer is a device that can use a prism to decompose light into different frequencies, and if you can measure the intensity of its frequency, then you can have a spectrum of the light source. From this, you can tell which elements are emitting that light, as each atomic element will emit very specific wavelengths. You can also tell if light is emitted by quantum processes or by thermal ones. May science be with you.